Well, let's unpack this. Today, we're diving into that it isn't just growing, it's genuinely reshaping healthcare, India's genetic testing market. Our mission for this deep dive is to really understand the powerful forces at play here. The drivers fueling its impressive growth, the challenges it's navigating, and some of the truly exciting cutting edge developments happening right now. And when I say impressive, I mean it. This market was valued at a pretty robust USD 69.24 million back in 2024. And the projection, it's anticipated to hit USD 103.70 million by 2030. That shows a significant compound annual growth rate, a CAGR of 6.89% during that 2025-2030 period. Pretty substantial.
It really is. And that growth isn't just a fascinating number on a page. It's a profound indicator of how India's health landscape is, well, truly being redrawn from the ground up. What's particularly significant here, I think, is how this sector's expansion has the potential to fundamentally reshape public health and individual well-being across the entire country. So yeah, this deep dive isn't just about the raw numbers. It's about illuminating the underlying shifts and, frankly, the profound implications behind this progression for healthcare, prevention, and personalized treatment for millions.
Right. So with that kind of explosive growth, my immediate question is, well, what's really behind it? What's pushing this forward so fast? Is it mainly, scientists and doctors with new tech, or is there a real pull from the public too? What are the key factors fueling this incredible expansion in India's genetic testing market?
It's a fascinating mix, actually, both push and pull. One of the most foundational drivers is definitely a significant increase in public awareness and acceptance. And this isn't just about people knowing what genetic testing is. It feels like a real societal shift towards proactive health management. The insight here is that many Indian consumers seem to be moving from that treat when sick mindset towards more of a prevent and personalize approach. And that shift is largely driven by, increased understanding and, crucially, trust in the technology itself.
Okay, so people are more informed, more proactive.
Exactly. And this is actively supported by things like educational campaigns, plenty of media coverage, and importantly, much more open discussion within the medical community. So as more individuals become informed about the benefits like, disease prevention, early diagnosis, guiding personalized treatment plans, they're naturally more inclined to actually seek out these services.
And I imagine that works hand in hand with the technology itself. The pace of advancement there feels, well, mind-boggling sometimes.
When we talk about technologies like next-generation sequencing, NGS, or polymerase chain reaction, PCR, and microarray analysis, how have these really changed the game for this specific market in India?
That's where the magic really happens, isn't it? These aren't just fancy terms, they're the engine. They've driven down costs dramatically and increased accuracy to the point where personalized diagnostics are now becoming, well, economically viable for a much broader segment of the Indian population. Not just the elite anymore. These innovations have made testing faster, incredibly accurate, and much more cost-effective than before. And what's particularly impactful is their ability to analyze multiple genes or even entire genomic regions all at once.
Simultaneously.
Yes, simultaneously. That's a massive game changer, especially for understanding and diagnosing complex genetic disorders. It allows for a much more comprehensive picture. And sadly, I suppose another big driver is just the reality of health in India. The increasing prevalence of genetic disorders and chronic diseases. We're talking about a whole spectrum, right? From rare genetic diseases to hereditary cancers, chromosomal abnormalities.
Exactly. As the incidence of these conditions continues to rise, unfortunately, there's a corresponding and quite urgent increase in the demand for genetic testing. It becomes crucial for early detection, for robust risk assessment, and for guiding genetic counseling. All vital steps in managing and hopefully preventing the progression of these diseases.
That makes sense. A growing need meeting improving technology.
Precisely. And it's interesting how that pressing need is being met, at least in part, by government initiatives. We're definitely seeing government programs and schemes actively working to enhance healthcare delivery in this specific space. Take, for instance, a really concrete example. Just back in February 2024, the Genetic Research Center, the GRC, at ICMR's National Institute of Reproductive and Child Health in Mumbai.
ICMR NIRCH, right?
Yes, ICMR NERCH. It became Maharashtra's very first government facility to offer complimentary genetic testing and counseling for rare diseases. Free.
Wow, complimentary. That's huge.
It is. And this isn't just a small pilot. It attends to referrals from municipal corporations, government medical colleges, hospitals near Mumbai, and even from rural communities across Maharashtra. So this is a clear signal, I think, of the government's role in investing in the necessary infrastructure and actually subsidizing costs to try and drive wider adoption.
And that government push for access seems to align perfectly with this bigger shift happening in medicine globally.
Hmm.
The whole move towards personalized medicine and targeted therapies. Genetic testing seems absolutely central to that.
Mm-hmm.
What does it really mean for an individual when their treatment plan can be tailored to their unique genetic blueprint?
Well, it fundamentally means moving away from that old one-size-fits-all approach to medicine. Personalized medicine aims to tailor treatments based on an individual's unique genetic makeup, sure, but also their lifestyle and even environmental influences. Genetic testing provides these absolutely vital insights into, say, genetic predispositions, how a person might respond to specific drugs, their particular disease risks, and all that leads to much more precise diagnoses and ultimately better treatment decisions.
Like getting a custom-tailored suit for your health, maybe.
That's a good analogy, yeah. Instead of just buying off the rack and hoping it fits. So we've painted a pretty rosy picture so far: growth, innovation, government support. But like any ambitious journey, this market faces some very real roadblocks. What are the biggest hurdles, do you think, preventing this potential from truly flourishing across the board?
That's a critical point to bring up. Because despite all the clear benefits, what's fascinating here is that the first, and perhaps still the most significant barrier, is simply cost, affordability. Even with technology bringing prices down globally, many of these tests remain relatively expensive for a large chunk of India's population, especially for those in low and middle income groups.
Right, the price point is still a major issue.
It really is. And the problem is often compounded by, well, limited reimbursement policies from insurers and generally inadequate insurance coverage for these kinds of tests, which often places a considerable financial burden directly onto the patients themselves.
Hmm. And closely tied to affordability is the issue of access, isn't it? Particularly when you look outside the major cities into India's vast rural and underserved areas. Genetic testing facilities are just overwhelmingly concentrated in urban centers. That leaves rural populations facing some pretty significant barriers.
What kind of barriers are we talking about?
Well, you've got geographical distance, obviously. Then there's limited infrastructure, shortages in trained healthcare professionals who can administer and interpret tests, often a lack of general awareness that these tests even exist.
Cross-transport, socioeconomic factors.
Exactly. Add inadequate transportation, deep-seated socioeconomic disparities. All these factors combine to create a massive gap in equitable healthcare delivery. It's a major challenge, frankly, that needs some really innovative solutions if everyone is going to benefit.
Those are definitely significant hurdles, huge challenges. But here's where it gets really interesting. There are also powerful positive trends emerging that seem to be actively counteracting some of these challenges and are fostering continued growth. First up, we're seeing a clear expansion of healthcare infrastructure right across India. There's a growing number of diagnostic laboratories and genetic counseling centers being established. And this seems to be thanks to both public and private investments. This expansion directly improves access to these crucial services, not just keeping them in the big cities, but increasingly reaching into some rural communities as well.
Yeah, that infrastructure piece is key. And supporting that growth is the general trend of rising healthcare expenditure across the country. As India's economy continues to grow and household incomes rise, there's just a corresponding increase in spending on healthcare by individuals and families.
People prioritizing health more.
Exactly. And it isn't just about treating illness anymore. It's fueling a demand for more advanced medical services, including genetic testing, as people place more value on preventive care and early disease detection. And another factor is the growing availability of health insurance coverage specifically for these services. That's making them more affordable and accessible to a larger part of the population, which in turn helps drive market growth.
Okay, so the picture is complex challenges, but also strong positive trends. Now, maybe let's dive deeper. Break down the market into its most prominent segments. It helps understand where the real activity is concentrated. Looking at the type of testing, the data shows molecular testing really stands out as the leading segment. Could you maybe explain what molecular testing actually involves and why it's so dominant right now?
Absolutely. So molecular testing is essentially an umbrella term. It encompasses a pretty diverse array of techniques that specifically analyze nucleic acids, so DNA and RNA. The goal is to detect genetic variations, mutations, or specific biomarkers associated with various diseases. Its dominance really comes from a combination of factors. Technological advancements are huge, offering highly sensitive, specific, and efficient methods like, as you mentioned, PCR, next-generation sequencing, and also AVESH. Yeah, fluorescence in situ hybridization. It's a technique that essentially paints genes or chromosomes with fluorescent probes to help identify abnormalities.
Mhm.
Really powerful. And beyond the tech, its wide clinical utility is just unparalleled across so many different medical specialties.
Right, the applications are broad. So for genetic disorders, it means faster, more accurate diagnosis for inherited conditions like, say, cystic fibrosis, thalassemia, Duchenne muscular dystrophy, allows for early intervention.
Precisely. And then in infectious disease diagnostics, it enables really quick detection and identification of pathogens, bacteria, viruses, parasites, which is obviously vital for timely treatment.
But you mentioned oncology earlier, cancer care. It seems like molecular testing has really revolutionized that field.
Oh, absolutely. It's changed how we approach cancer. By identifying specific mutations and molecular biomarkers in a tumor, it helps guide targeted therapies treatments designed for that specific cancer profile. It can help predict how well a patient might respond to a particular treatment and even monitor disease progression over time. It's fundamental to modern oncology.
Okay, so that's molecular testing. Now, moving to application insights, the data highlights reproductive cancer screening as another major player. Why is that specific application so prominent?
Well, it reflects its critical role in preventive healthcare and disease management, especially for cancers that disproportionately affect populations. These are genetic tests specifically designed to assess an individual's inherited risk of developing certain cancers affecting reproductive organs. Think breast, ovarian, uterine, prostate cancers. Several factors contribute to its dominance here. Unfortunately, the high prevalence and mortality rates of these cancers in India is one factor. Another is a growing awareness and emphasis on cancer prevention generally.
And more screening programs available.
Exactly. And the increasing availability of targeted screening programs specifically for these types of hereditary cancers.
It seems particularly significant for conditions like breast cancer, which is a major public health challenge in India, right?
Hugely significant. Genetic testing for those hereditary susceptibility genes, especially BRCA1 and BRCA2, is absolutely crucial here. It helps identify individuals who are at an increased risk of developing breast and ovarian cancers due to inherited mutations. This then leads to personalized risk assessment, allows for enhanced surveillance, more frequent screenings, for example, and can even guide decisions about preventive measures, like risk-reducing surgeries in some cases.
And ovarian cancer, too. That's notoriously hard to detect early.
Very hard. And that's where genetic testing comes in again. For ovarian cancer, testing for hereditary syndromes like Lynch syndrome or hereditary breast and ovarian cancer syndrome, HBOC, helps identify those with an elevated risk. This allows for targeted interventions and surveillance strategies that just wouldn't be possible otherwise, hopefully improving clinical outcomes.
Makes sense. Okay, one more layer, regional insights. The analysis shows North India dominating the genetic testing market compared to other regions. Why North India specifically?
Yeah, that's quite clear in the data. North India's prominence isn't really accidental. It stems from a concentration of several key elements. You have significant healthcare infrastructure there, many leading research institutions, strong economic development in certain pockets, and important population demographics. Specifically, the National Capital Region, the NCR, encompassing Delhi, Gurugram, Noida, Ghaziabad, acts as a major central hub for healthcare services, research, and innovation.
And Delhi's role as the capital.
That's a big part of it. Delhi is home to premier medical institutions, large government hospitals, major research centers, all of which drive advancements and, critically, access to genetic testing services. Its rapid economic growth and the presence of these state-of-the-art facilities really helps solidify its position as a key player in this market.
Got it. Okay, so that gives us a great breakdown. Now, to bring this deep dive right up to the minute, let's touch on some very recent developments, things happening almost as we speak. Just last month, May 2025, there was news out of Lok Nayak Hospital in New Delhi. The chief minister inaugurated 3 new facilities there. This included a medical genetics ward, apparently the first of its kind in any Delhi government hospital, and it aligns with the National Medical Commission's Center of Excellence for Rare Genetic Disorders initiative.
That's impressive.
Yeah, and they also opened a lactation management unit, an LMU, to support new mothers, and a nucleic acid amplification testing, or NAT, laboratory, which is crucial for rapid disease diagnosis. This new genetics ward is specifically set up to provide comprehensive diagnostic, treatment, and counseling services for rare genetic conditions,
Yep.
even including prenatal care.
That's a truly significant step forward for public health infrastructure in the capital. Really positive news. And looking back just a bit further to January 2025, there was that report about Telangana seeing a remarkable surge in premarital genetic testing.
Ah, yes, I saw that, a 5-fold increase.
Apparently so, over the past decade. Amid concerns about a rise in rare diseases among newborns, couples are increasingly seeking these tests before marriage to assess the risk of transmitting inherited disorders. Doctors in Hyderabad reported this surge, attributing it to, well, the factors we discussed earlier: greater awareness, improved accessibility, thankfully declining testing costs, and also a rise in fertility-related concerns among couples.
And what conditions are they typically screening for in that context?
The reports mention conditions like spinal muscular atrophy, or SMA, thalassemia, Duchenne muscular dystrophy, DMD, Fragile X syndrome, FXS, and cystic fibrosis. These are conditions that, while individually rare globally, collectively pose a pretty significant health challenge in India due to population size and carrier frequencies.
And it's not just government initiatives driving things, right? Private collaborations are also making waves. I saw something about a Pune-based startup, IAUSWE. In May 2024, they unveiled DNA testing services.
That's right. In collaboration with Map My Genome, which is a well-established player with, I think, over 23 years of genomics expertise, their service aims to offer comprehensive insights into health, wellness, even ancestry. And importantly, they highlighted that it includes complementary expert genetic counseling, tailored guidance based on individual goals, lifestyle, family history, and, of course, the genetic results themselves.
So it seems like activities happening on multiple fronts: public sector, private sector, increasing consumer demand. Okay, so what does this all mean? We've sort of unpacked the dynamic nature of India's genetic testing market. We've acknowledged its rapid growth, the innovative forces propelling it, but also those persistent challenges like cost and access that still require significant attention.
Yeah, I think what's really fascinating here is how you see this blend, this convergence of continuous technological breakthroughs, that rising public awareness we talked about, and increasingly proactive governmental support. It feels like this combined effort is genuinely transforming healthcare in India. It's making personalized medicine, which sounded futuristic not long ago, a tangible reality for more and more people. It really represents a shift in the landscape, moving away from purely reactive treatment towards something more proactive, more individualized.
Right, so maybe a final thought to leave everyone with. Consider how the continued expansion of genetic testing, particularly if we see real progress on increased accessibility and affordability, could fundamentally reshape not just individual health management, but entire public health strategies across India's incredibly diverse populations. It really could help create a truly preventative and personalized healthcare landscape for the future.